example, p of x is equal to x cubed minus 7 times 2x squared plus x plus 3.
Okay.
Okay, so when I look at this function, what I see is I see two separate set of parentheses which are grouping together two separate functions. And the way that they're being combined is that they're being multiplied together. So this is a product of two functions. I'm going to use the product rule to calculate the derivative. All right, so when I write this down, I'm going to identify x cubed minus 7 as my first function, and 2x squared plus x plus 3 is my second function. Now, because this is our first time using the product rule, I'm going to write out this intermediate step. You may not want to do that after you've done about 50 of these, but maybe for the first 49 you do want to do this. Okay? So our derivative says first, which I'm going to copy down exactly, times the derivative of the second. And I'm going to literally write this as d over dx of 2x squared plus x plus 3. So first times the derivative of the second. Plus second, that's 2x squared plus x plus 3 times the derivative, d over dx, of the first, derivative of x cubed minus 7. Now I'm not done yet, but I've at least taken a step toward calculating my derivative. I still have these derivative formulas to say take the derivative of the stuff inside the parentheses, but at least I've written out the formula. Okay. So now that we've done this, the x cubed minus 7, we literally carry that along. There's nothing in front of it. Now this d over dx, take the derivative of the thing inside the parentheses. Well, now the derivative of 2x squared, well, I'm going to bring that 2 down in front. And I can multiply that 2 in front by my new power. So that automatically becomes 4x to the first. My derivative of x is 1, and my derivative of a constant sitting by itself is 0. So I'm going to write the plus 0 this time, but after about the first 49 of them, then I'll stop writing that plus 0. So we have first times derivative of the second, plus second, which I copy down exactly as is, 2x squared plus x plus 3, times the derivative of the first, derivative of x cubed minus 7. So I'm going to use the power rule, and I have 3x squared minus the derivative of 7 is 0. And so this is my derivative of the original function. All right, any questions about that derivative right there?
Is that where you're saying you don't really need to simplify past that?
Yes.
Okay.
So here, especially with the product rule, I don't want you to expand all this out. Now,
You could, yeah.
you don't need the minus zeros on there, but the rest of it, I would not recommend multiplying that out. So what you've done here is you've demonstrated the calculus. Beyond that would be algebra. Like if I had a 7 here or something?
Would that make that first section?
Then I would have 7 times everything. Good. Other questions? Okay. So this product rule is kind of random. I mean, I'm just tossing this up on the board and we're using it. I want to look at an example where we can calculate our derivative in two different ways and make sure that this product rule is at least valid for one example. All right, so let's take a look at y is equal to x squared plus 3x times 5x minus 2. And we're going to calculate the derivative of this function in two different ways. Method 1 is that we're going to use the product rule. So what that tells me is that I'm going to identify my first function and my second function. And they're multiplied together, so because I have a product of two functions, I'm going to use the product rule. So my derivative, y prime, is going to be first x squared plus 3x times the derivative, d over dx, of the second, 5x minus 2. First times derivative of the second, plus second, 5x minus 2, times derivative of the first, d over dx of x squared plus 3x. Okay, so I've written out the product rule, and this is our derivative, but we're not done computing the derivative. We still need to take the derivative of the 5x minus 2 and the derivative of the x squared plus 3x. So our y prime is x squared plus 3x. Derivative of 5x, that's going to be 5. And that makes sense for two reasons. Number one, if I have y equals 5x, that's a line whose slope is 5. The other way I can think about that is 5x is really 5x to the first. And so when I take a derivative, I've got 5 times 1x to the 0, and x to the 0 is a 1. Okay, so the derivative of 5x is 5, and the derivative of a 2 standing by itself is 0. Plus, we've got 5x minus 2 times the derivative of x squared minus 3x. So that derivative will be 2x plus 3. Okay, so this is one way to calculate our derivative, is to use the product rule. Method number 2, you know, if you happen to get to the test, or if you're working on a homework problem and you don't have any reference materials to go back and you say, darn it, I forget what this product rule says. I forget that the product rule says the derivative of first times second is first times derivative of the second plus second times derivative of the first. I forget that rule. What am I going to do? Well, one thing you can do is take your original function and multiply it out. So method 2 is to simplify our function y first. So y was originally x squared plus 3x times 5x minus 2. And so we can expand this all out and then simplify some terms. So I can distribute this x squared, so I've got 5x to the third minus 2x squared. And then 3x times 5x gives me 15x squared minus 6x. And so now, when I simplify this, I can combine some like terms. My x squareds combined, so I have 5x cubed plus 13x squared minus 6x. So far, zero calculus has happened on this problem. This is strictly algebra. All right, now I look at this function, and I say, oh, this is a nice friendly function. It's a bunch of small functions combined together with pluses and minuses, so I can take the derivative of each of these terms separately. So my derivative, y prime, I bring that 3 down in front, I can multiply it by the 5, that'll give me 15 x squared, plus, bring that 2 down, 2 times 13 is 26, x to the first, minus 6. Well,
So this second way seems a lot easier. Why would we even use it?
that's a really good question. So this is a really easy function to multiply out. Now, we're going to start to see functions that are ridiculous to try and multiply out. And so, for example, one of these might have a square root over it and the other one doesn't. Or they may involve terms where when you multiply together, one has a cosine and the other one has just x's to powers, and then you'd have things multiplied together that you have to do a product rule in those individual pieces. Life can start to get ugly. So this is an example where we can do this both ways. But most of the time, you won't be able to multiply it out. Now these don't look exactly the same. I mean, here I'd have to simplify this a little bit to convince myself that it was in fact the same as over there. So if we simplify this first method, we have 5x squared plus 15x plus 10x squared plus 15x minus 4x minus 6. And so looking at y prime, and combining some terms, we've got a total of 15x squared. And then we've got 30 x's minus 4 of them gives us 26 x's minus 6. And so they are in fact the same. Okay?
So for the most part, are we going to be doing method 2? Because when can we not do the product rule?
So for the most part, you're going to be using the product rule for something like this. If you have something that is, each function is kind of quick and easy and maybe only involves 2 terms each, then you have an option of either one. My goal in doing this was to demonstrate that whether you use the product rule or whether you simplify first, you should get the same answer. I would say about 80% of the time, you're going to want to use the product rule. This is one place where simplifying first is easier. Okay, questions or comments? All right.